Hello, welcome to lesson 5 for our physics unit. I work out, quoting an old song if you remember this song. So today we're going to be learning to apply W equals F times D, or work equals force times distance, to solve equations about the change in motion or energy for an object. So what is work? We're going to define it, like the physics term, obviously. You're familiar with how we use the word work, I hope. For the formula for work, and then some examples of work. So, what is work? Work is the amount of force applied over a distance. So, work is related to the energy of motion, kinetic energy. In this GIF, the girl lifting weights is doing work. Obs. She's applying a force to the weight, and it's being moved a distance, right? So what is force? What is distance? Force is a push or pull, right? We talked about this before. And the unit we use to talk about force is newtons. 1 Newton is enough push or pull to accelerate, to speed up a 1 kilogram object 1 meter per second. And we'll go into more detail on this later. Okay? Distance is how far something travels. We use meters in physics typically, which is about 3 feet. It's close to, but not quite a yard. So what is that formula? We mentioned before. It's work is equal to force times distance. W equals F times D. So let's say this girl here is applying a force of 200 newtons to the weight, and it's being moved a distance of 0.5 meters, so about half a meter. It's about a foot and a half. So 200 newtons times 0.5 meters equals 100 J. Oh, right. So joules are kinetic energy. Actually, joules pretty much all energy, but let's stay with kinetic for now. So if work equals force times distance, right? If this girl was squatting twice as deep, so a whole meter down, whole meter up, but had half the weight, she would do the same work on it. That's why, if you have good form and move the weight a lot, you get just as much work out of it, even if it's less. Here we have only 100 newtons, right? But it's 1 meter, and we still get 100 joules. That looks painful, wouldn't you say? So when work is done, it is always a force over a distance. As I try to get this thing, give me a second. The lights are back. So work's always a force over a distance, right? So in this GIF below, a force is being applied on a man's face over a distance. See how the ball and his face are moving. The total work done is always how much force, how much push or pull, multiplied by how far you're pushing. More force or more distance is more work. So in this GIF we have on the screen, the player is doing work to their own foot to apply energy. So they're pushing their foot, force over a distance, F times D. That energy gets transferred to the ball over another distance, how long he's kicking it for before it leaves his foot, F times D. And that's why the ball has the sauce. Just look at that. If he had a shorter kick, less distance would cause less work. If he kicked with more force, the exact same distance of kicking, there'd be more work. So let's do some sample math here. A force of 20 newtons is applied to an object for 3 meters. 20 times 3 is 60 newtons, or meters, aka joules. So 12 N applied to an object for 4 M. Here's another example. 12 times 4 is 48. 12N times 4M, 48J. Okay? An object has 32 joules after a force is applied to it for 4 meters. How large is the force? Well, this is going to be a little different. We haven't tried it this way yet. Well, 32J equals a force times 4 meters. Well, let's move the 4 meters over. 32J divided by 4M equals the F, the force, or 8 newtons. And that's it. That is our whole lesson. Good luck with the work, and if you need any help, let me know.